Okay, here we are. I'm going to go over the homework that was graphing linear inequalities in two variables. So you should have, hopefully, let me see if this works real quick. Hey, this is far from working. Give me 1 second. We'll fast forward through this part. This works. Okay, so you should have in front of you the linear inequalities in two variables. Okay. It describes kind of in words what to do, and I'm going to somewhat quickly go over two of these problems. The first one and probably the fourth one. So let's see. Again, this assumes you've already read all the notes and have some understanding of how to graph a line. So if you notice, I have the 3x plus 2y has to be greater than or equal to 8. So in order to start, I need to get that into y equals mx plus b form. I need it in the right slope and intercept form. So I'm going to subtract 3x from both sides. And then divide each side by 2. And again, everything over here is being divided by 2. Rewrite it. Right. And notice my slope is a fraction. This is the same as negative 1.5, but because I'm going to be counting boxes, it's probably best to leave as a fraction. So again, I have this basic linear inequality, but I'm going to graph it like it was a line with a few minor exceptions. So I'll start with the y-intercept, right? And remember, this is slope. Slope is measuring how things are changing. So I go to my y-axis at positive 4, and put my first dot. And from there, basically count my boxes. This would be down 3 to the right 2, down 3 to the right 2. Remember, slope is change in y over change in x. 1, 2, 3, down 3 to the right 2, down 3 to the right 2. Or potentially could do that opposite and go up 3 to the left 2. And then you get a few dots where you can then draw the line. And here's where it gets a little weird. Are you drawing the line with kind of a solid line or a dotted line? Okay, and what we're trying to communicate are all y values that are greater than or equal to. So because this has the or equal to symbol, I'm going to connect it with a solid line. Okay, so I'm going to do my best here connecting these dots with a solid line. And probably use a straight edge. Whoop, missed that one by a little bit, but again, being on the smartboard, it's always off by a tiny bit. I apologize. But I'm trying to connect all those dots. Okay. And again, I used a solid line because it's the or equal to. And at this point, I have to decide, am I shading things that are below or above that line? Okay. And again, the notes talk about how to do this. But basically, pick any point. It does not matter what point. I know sometimes I talk about the point 1, 1 or 0, 0, but you're picking any point anywhere that's not on the line and seeing how it plays out in the inequality. So I'm going to pick 0, 0 because it's really easy to work with. Okay? So testing, test with x0, y0, right? So that's kind of that point right there, the origin. And I just want to see, how does this play out? So let's see, 3 times 0 is 2 times 0 greater than or equal to 8. 3 times 0 is 0, plus 2 times 0 is 0. So basically this is saying 0 is greater than or equal to 8. No, it's not. Right? That's not true. So what that means is I do not want to shade where that 0, 0 is. Right? So if that were true, I would shade down here. But being how it's not true, I'm basically shading this. Right? right? I'm shading basically all the XY points over here. Right? There's an infinite amount of points that I'm shading, and it doesn't stop because the grid goes. I mean, I'm basically shading forever over there. Okay? And that means every single point that's shaded would make a true statement out of that inequality, even the points on the line, right? Because it says greater than or equal to. So if I were to pick one of these exact points, like 2, 1, that's exactly on the line, a 2, 1 would make an 8 is greater than or equal to 8, which it is. So that's going over problem 1, and in a second I'll go over problem 2. Okay, let's erase all this. Let's erase all this. For those in class, you know sometimes like Smartboard gets a little funny here, so I gotta knock that out. And let's see if we can do number 4, which was 2 x minus 3. Okay. Here we go. What did it say? I gotta get this right here. Plus x. Less than 12. So I'm not doing this one now, I'm doing number 4. I'm trying to get it in the correct format, so let's distribute. Combine like terms that are on the same side. And attempt to solve this for y. So, hopefully all this makes sense. I'm distributing, combining like terms, trying to get the y by itself, and hopefully you notice in the next step I'm going to be dividing by -6. Okay, we got to remember, when we divide an inequality by a negative, we flip the symbol. So technically, we're dividing everything by -6. Okay, and we're going to get y, flip the symbol, because I divided by a negative. Okay, -3 divided by -6 is the same as +1/2. And over here, -2. Again, I'm going to graph it. Knowing my y-intercept is -2, so the first dot's at -2, and my slope is up 1 to the right 2, up 1 to the right 2, up 1 to the right 2, or down 1 to the left 2, down 1 to the left 2. Okay, but on this problem, instead of connecting with a solid line, right, this symbol is meaning I cannot also equal, right? I don't want these two things equal, just one, this is strictly greater than that. Okay, so the line, in this case, is a dotted line. To communicate, that's the boundary, between, I guess, the space I'm trying to shade in and the space I'm not trying to shade in. The dotted line is communicating, I don't want to be on the line. The line is just the boundary because it doesn't have the equal to. I pick some random point. Again, I'm going to pick 0, 0. I'm not going to show as much work here. Again, 0, 0 is pretty easy to work with. And I try to see what happens in the original. It's always helpful to go back to the original statement. So let's see, can we find that original? Okay. So I'm going to be putting 0, 0 in. And seeing if it makes a true statement. Okay, so I'm getting 0 is less than 12. Yes, it is true this time. 0 is less than 12, And since 0, 0 is kind of up above the line, I'm going to shade everything above the line. Again, what that's communicating is everything that just got shaded would make the original inequality true. Okay? That should be enough, pause it, slow it down, fast forward it, do whatever you have to do. That should be enough to be able to finish the homework. And this is now no longer a challenge problem. I want you to attempt it. This will get graded next class. Thank you.